I am here to explain the topic, which is the subgroup and group under the abstract algebra. So here I choose exercise 3 and I have this problem, and in the under of exercise 3 I select number 2. So in the number 2 I have a problem which is integers comma positive with integers comma positive, where null set of n is equal to negative n, for n is an element of integers. So first, my role here is to identify if this problem is isomorphism. So first, I will define what is isomorphism. Isomorphism is a homomorphism that is one-to-one and onto. Take note that homomorphism is same structure and same shape. Another one, you can only call isomorphism if the structures and the shape is homomorphism and bijection. Last one, iso is equal and morph is equal to shape. This two is derived from here, isomorphism. So let's identify if this is isomorphism or not. So take note that in our problem we have null set of n is equal n. So take note that null set of n is equal n, and negative n, and we assume that we have null set of n plus m. So null set of n plus n is equal to negative null set of n plus m, because we derive from here. So that's why we have this negative n plus n. Using the distributive property in multiplication, we have this negative n plus negative m. So null set of n plus n, I told you lately that null set of n is equal negative n. So let's substitute this negative n into null set. So that's why we have null set n plus null set m. So therefore, that the null set n plus m is congruent or equal to null set of n plus null set of m, because we are talking about positive here, and here also is positive and positive also. So therefore, this problem is isomorphism. That's all for today. I'm Adrian Jay R. Thank you.
Okay, good day everyone. I am here today to explain my choosing exercise. I have two exercises. So under the exercise 4, I have choose number 11. So the question is, all n times n diagonal matrices under matrix addition. To determine the group of these diagonal matrices, so we have, suppose the augmented matrices are the set of A, B, C, D, E, F plus U, V, W and X, Y, Z. So we have the equals of A plus U. So A plus U is equal to A plus U. Then B plus V is equal to B plus V. So and so on. So we have A plus U, B plus V, C plus W, D plus X, E plus Y, and F plus Z. Then therefore, n plus n diagonal matrices under matrix addition is a group, because the addition of this result having positive or addition in a group of matrices. So note that the identity element is the zero matrix and the inverse of the matrix A is the matrix negative 1 A. So the next one is I have chosen exercise 5. Then below this we have number 22. The question is describe the elements in the cyclic subgroup of GL of 2 in real numbers generated by the 2 by 2 matrix. So we have 0, negative 1, and negative 1 and 0. In short, we have the identity matrix. So we have consider the A is equal to 0, negative 1, so copy this, and 0 is an element of GL of 2 in real numbers. Then observe that A raised to 2 is squared. So we have 0, negative 1 copy, and then copy also to square this matrix 0, negative 1, and negative 1 and 0. So we have the identity matrix is equal to identity matrix of sub 2. In this case, we have the identity matrix sub 1. So it's equal to sub 1 in this sub 2. So then we have that A is an raised to 2n is equal to, by using the exponential rules, so separate. So we have the open parenthesis A raised to 2 close, and then raised to n, and then is equal to identity matrix. So we have this identity matrix over 2 in raised to 2. So because A raised to 2 is equal to identity matrix. Okay, and A raised to 2n plus 1 is equal to A raised to 2n A, because this one is equal to A matrix. So then equal to I sub 2 times to A is equal to A, because when we multiply this both matrices, we have the result of the same answer. So we have the identity matrix, or A, for all n is an element of integers. Thus A is equal to element of set of A raised to n such that n is an element of integers. So we have we have the set of I raised to I sub 2 and A. So we have this, and then the result is we have the I sub 2 is equal to 1 0 0 1, and then the and then A is equal to 0 negative 1 and negative 1 and 0. So therefore this subgroup is generated by the 2 by 2 matrix by this given matrices. So that's it. So thank you.